Okay, afternoon everybody. I feel as though some of the talks that have been presented already are probably saying everything that I'm going to say, so it's not an apology, it's just that I think that they've probably done it better than I will. I will start, however, by just really giving you a bit of context for the material that I'm going to be focusing on. Looking at the impacts of sea level rise, I noticed some of the presentations yesterday were about summarising chapters. Well, I thought I'd summarise the chapter of me and Jason Kirby's work in the treatise on estuarine and coastal self-science. So this is my summary of chapter 3.03. Not quite the same as an AR5 chapter, but hopefully it gets fairly close. I'd like to start off, this isn't really in terms of any kind of detailed revision, but it's just really reflecting on some of those pressures that are impacting on coastal resources, coastal populations, coastal settlements at the present day. Sea level rise obviously being one of those. And as we just heard just before the break, extreme events. But we shouldn't, of course, forget the fact that there's things happening on land as well. And clearly an added pressure on coastal resources comes from population growth, increasing world population. And whilst that's happening generally, if we kind of look at how that's distributed, really the main part of population growth in the world is focused at the coast. So I'm sure many of you are familiar with this statistic, about 2/3 of the world's population lives within the coastal zone. But indeed, you know, that's a very important fact, and it emphasises the importance of the work that you're doing, because it's absolutely critical and crucial, because it feeds into being able to sustain these large populations that live at the coast. These large and growing populations. Over there on the left-hand side, for example, most of the emerging megacities of the world, those that have a population greater than 10 million inhabitants, the majority of those are of course coastal, because of all of the fantastic opportunities that living in the coast, or at the coast, actually offers. So as well as obviously the changes in the pressures from, let's say, the hydrodynamics, from the extreme events, from the base level of sea level rise, there's obviously increasing pressures that come from population and therefore pressures on resources. Okay, but this is the key question. Obviously, for those people who make decisions at the coast, those folks who either look after sea defences or look after coastal resources in terms of areas that need protection, they're always asking these questions, and they're really important questions. How high is sea level going to be in terms of the future projection? When's it going to happen? What are the probabilities like? So it's absolutely critical. It's essential that what we're doing is feeding that information through to the folks who are going to use it. And hopefully that's something that I'm hoping to be able to emphasise in this presentation. The importance of ensuring that our knowledge is actually passed down to folks who are then going to use it to make sure that those resources are used sustainably. So I thought I'd start with some views of catastrophic sea level rise. I'm using catastrophic in inverted commas there because it doesn't look terribly catastrophic. I thought it would be nice in 1996 to take some views of the Wirral Peninsula and around Liverpool during extreme high tide. And you can see that there's a bit of flooding on the car park at West Kirby, and the water level comes right up to the coastal defence. And at Parkgate Marsh, where we had our field trip, we were sat in the boathouse having our lovely lunch, wondering if the water level ever got over the salt marsh, and here it shows the salt marsh being submerged by that high water level. And here we can see a catastrophic effect in terms of obviously a film crew and people coming out to have a look at the high tide. And just immediately off to the right here, there's actually a pub, and I'm sure that people would have been quite happy with the excuse not to be able to leave the pub because the water level was particularly high then, and they'd have to wait for another hour or so. So in these sort of cases, it's very difficult to justify that sea level rise is a real threat to coastal populations. In fact, probably what we need to focus on is how we kind of communicate the changes that are likely to take place in the future. I always thought this was a great study from Paolo Pirozzoli, where he was looking really to demonstrate when sea level rise changes from being an inconvenience to being something that is perhaps life-threatening. Indeed, you know, I'm not bragging here by any means, but we were having a conversation this morning with the local authority here at Sefton, where we were addressing this specific question, is that when does sea level rise make that conversion? How high should we keep elevating sea defences until we reach a point where it's no longer economic to do so. In fact, there was an argument made that if you kept raising those sea defences, you would actually be increasing the value of the development that would be taking place in the lowland area, and so you would actually keep adding to your justification for raising sea defences. However, just to focus back on this presentation, I think the nice illustration here is where we've got almost like a probability distribution function of street level and a probability distribution function of tidal level, and of course where they overlap, that's obviously our concern. And as sea level rises, whatever scenario we use, or whatever projection, whether it's 30 centimetres, whether it's a metre, in essence what we're doing is increasing the overlap here. And again, in Paolo's work, we looked at 30 centimetres of sea level rise, illustrating 75% of tides would flood St Mark's Square, and therefore it would be underwater for a quarter of the year. If we were to look at a 1 metre sea level rise scenario, then 40% of street level would be below mean sea level, and St Mark's Square would be more than half a metre below mean sea level. Okay? Clearly massively inconvenient, unless of course you happen to take your canoe to work with you, so there would be options for that. But of course, this was the sort of information that fed into, I'm sure, the design and the construction of the Venice Lagoon Defence. So again, this is the clever use of data, the important use of data, to be able to justify decision making at the coast. Now, I don't suppose many of you are geographers or physical geographers in the audience, and that's no bad thing. But something that is very prevalent within physical geography is the work of Wallman and Miller, where they looked at the behaviours of river systems. In essence, what they showed is that they were looking at the frequency distribution of river flow, and they were looking at the amount of sediment transport and the amount of erosion that took place under those different events. They came up with this classic curve that shows that it's not necessarily the most extreme events that those that do the majority of change within a river, but those that are fairly frequent, but certainly not the biggest events. And I suppose that's the question to pose here, is that in terms of coastal response to sea level rise, is it the slow progressive rate of change of millimetres per year, the gradual response, which is the thing that we want to draw people's attention to? Or alternatively, it's the more catastrophic view, the more extreme events that we heard presentations on just earlier, where we can get changes of the elevation of the tide of the orders of metres in a matter of hours. And of course, it's these events that draw our attention. I'm sure you're all very aware that Hurricane Sandy took place a year ago today. It actually appeared in the news yesterday, so it's not as though it was an event in the past. Here it is reappearing in the news. Ellis Island Visitor Centre had only just reopened a year after this event. And so clearly when we look at events like the storms, the extremes, they obviously draw people's attention. Perhaps these are the sort of events that we really should be emphasising in terms of planning and managing coastal resources. Sea level rise is something that's bubbling away, something that's there and underpinning all of this. But of course, it's obvious that perhaps these extreme events will draw attention, and therefore, they're likely to be the focus of coastal planning and management, and therefore resource use. And so, of course, we see examples like this where lots of money have been put into engineering schemes in terms of storm surge defences, which can be put into operation periodically when there is an extreme. With the exception, perhaps, of 1997, because if the Thames barrage would have needed to be implemented at this time when the sand kite ran into it, it wouldn't have been a very effective storm surge barrier because sadly it was inoperable at that time. Anyway, that's an aside. I'm sure the engineers weren't expecting that to happen when that storm surge barrier was actually implemented. So I think one thing that we focused on so far is obviously being able to provide better information for stakeholders and coastal decision makers. And indeed the presentation just before lunch really kind of spelt this out in terms of the types of information that need to be delivered. Regionally or site-specific projections of sea level, which obviously have the different components to them, which build in land level change, which build in some of the gravitational effects. But this is obviously quite critical, rather than just having this global perspective. Providing something that can be rationalised locally and regionally is really important in terms of how that then converts into a decision-making process. However, that's only part of the solution in a way. That perhaps provides us with a problem that needs to be addressed. From my background, it's obviously really critical also to be able to emphasise the importance of understanding the coast in its entirety. And in terms of the extremes and in terms of sea level, we're only looking at one particular driver. But understanding coastal response now, and obviously how that's going to project into the future, requires a whole host of different factors to be understood. And that's why I really can't summarise that chapter 3.03 very well, so we have to go away and read it. And it's purely because there's so much detail, so much information that we actually need to have an understanding of. So here we are focusing on sea level, focusing on extreme events. But I kind of want to emphasise the role here that sediment supply and coastal geomorphology plays in terms of determining the coastal response to some of these drivers of change. And of course that doesn't preclude human intervention that seriously messes up the system from time to time, as illustrated here. Because clearly with a problem, it can very often be out-engineered. And we have so many examples of where we have particular problems at the coast where an engineering solution has been provided. I'm not suggesting that the engineering solution isn't a good solution. Sadly, however, this starts to obviously have impacts in terms of the coastal hydrodynamics, but more importantly, it starts to impact on the sediment budget. If we prevent erosion taking place in one place, then that generally means that we're limiting sediment being supplied somewhere else. So we're just creating a problem somewhere in another part of the coastline by protecting one part. And instead what we should be doing is promoting dynamic coasts. Those where the transport and the deposition and the erosion of sediment is all part and parcel of the way in which things operate. We don't treat erosion as a problem, we just treat it as part of the way in which a coastal system works. And of course that's now really the emphasis of coastal defence, maintaining healthy beaches. Beaches are incredibly good at, to a large extent, dissipating wave energy and to some extent reflecting wave energy. Even if we lose sediment, if we're able to buy enough through, let's say, income generation, through tourism, it means that beach recharge is an option that we have available to us to make sure our beaches remain healthy. Or alternatively, we now have what's known as the sand motor or the sand engine, which is an experiment which is being taken place on the Dutch coast. And indeed, the Crown Estate here in the UK are very much pushing this as an option for coastal defence. Again, it's not interrupting with any of the coastal dynamics. It's enabling sea level rise to take place. Storms will happen every now and again, but there's enough sediment in the system to make sure that catastrophic coastal erosion is therefore not a likely outcome of any of these futures. However, something that has been highlighted in some of the presentations is the impact that we're having on land. And we looked at the impact of dams in terms of the contribution to global sea levels. But the impact of dams obviously feeds into the supply of water downstream, and not just the supply of water, but also the supply of sediment. The majority of sediment that's found in the coastal zone, about 90% of it comes from rivers. It doesn't come from coastal erosion, it comes from rivers. So the more that we impact in terms of the transport of that material, the more we're clearly leading to coastal systems being exposed to erosion. I.e., they used to have a lot of sediment, and in fact through historical and archaeological human impact we've even accelerated the sediment delivery, but in recent years we're really starting to cut it back. So if we look at the Yangtze tidal flats, for example, and the Yangtze Delta, the history of the Yangtze Delta is built on a history of having plenty of sediment being supplied down that large river into the coastal zone. Rapid accretion, rapid expansion of the deltaic system, and this obviously supports a thriving and growing coastal economy. Within the city, we've got about 10 million people. Within the delta region, we've got the equivalent population of the Netherlands. As a result of the impact of the Three Gorges Dam on the Yangtze, what we're starting to see is reduced sediment accretion, and as a result of that, an enhanced vulnerability to erosion along that shoreline. So it's quite a change in the way in which the system operates. Our coastal systems, because of human impact during the last 5 and probably 3,000 years, have been operational during a period when there's been plenty of sediment available. As a result of our activity to try and retain water resources, we're now starting to decrease that sediment availability. So does that mean that healthy sediment systems are seriously being compromised? Well, yes, but it's not so bad, because at the coast, what happens in terms of sedimentation isn't just about sediment supply. There's also organic matter, so there's biological activity at the coast which might be able to help compensate for it. And I'm sure many of us are familiar with this option of perhaps reinstalling coastal wetlands or realigning the coast so as we can rejuvenate salt marshes. But perhaps what's very often overlooked are these wetlands that lie at the freshwater end of the system, something that we know as peri-marine wetlands. Peri-marine wetlands tend to look like this. They're a combination of reed swamps and these very wet woodland-type environments. In other parts of the world, we've got mangrove equivalents. And these actually serve some really useful functions. They serve an incredibly good sea defence function. They serve an incredibly good function in terms of regulating water levels. They even provide mechanisms for carbon sequestration, for being able to purify the water in terms of pollutants or excess nutrients. So there's a number of different functions that these peri-marine wetlands actually serve. We've basically got rid of most of ours, but they're very easily reintroduced. The great thing about peri-marine wetlands, as we've seen from our example, our exploration of, let's say, Holocene coastal response, is that here in the UK, in the south of England, is that there's a phase of coastal sedimentation in many of our estuaries, which shows the predominance of peri-marine wetlands during a period of sea level rise, during the mid-Holocene, where we were looking at rates of 6 to 3 millimetres per year, and actually very limited sediment supply because this was before significant human impact on soil erosion. And so these systems are very well adjusted to accelerated rates of sea level rise and reduced sediment supply. So simply we can think very carefully here about, okay, in areas where sediment availability might be low, the reintroduction of wetland systems might be an effective solution. You might think that's a bit pie in the sky, in which case I'll turn your attention to this village in Tamil Nadu, which had been in the Guinness Book of Records in 2002 for planting a vast number of trees at the coastline. This village fared incredibly well compared with its neighbours during the Indian Ocean tsunami in 2004. And really it was the trees that afforded them that protection. If you look at any of that footage, either from the Boxing Day tsunami or indeed from the Fukushima tsunami, just keep an eye on the trees as the breaking waves start to impact on the coastline. They tend to fare well. So again, it's about thinking in a joined up way that it's not just about steel and concrete, but perhaps healthy coastal systems in the future will be about sediment and about wood and about reeds and about wetlands. I'll not dwell on this too much, but it's also important to make sure that we understand that coastal systems respond at different scales, different time scales, different spatial scales. There's different lags and different sensitivities. So just as with recent emphasis on sea level studies, in trying to link what might be a tide gauge record with a salt marsh record, we should in essence be doing the same in terms of understanding coastal response to drivers such as sea level rise and extremes. And some work, just as an example, that we're just about to have published in the Holocene, focuses on the response of this back barrier wetland system. And here we've got a wonderful time series of change during the last 200 to 300 years or so. And that time series of change comes from the particle size distribution, which is preserved within sediment records. This is a very, very effective way of bridging between the process-based timescale, which determines particle size distributions, and how they then vary down core. So that's linking almost like instantaneous response to something that then gives us a record over several tens, if not hundreds of years in this example. We're also now exploring what evidence there is beneath the sea surface. So in terms of understanding the coastal system, it's not just about looking at our present day coast, but we can actually now look underwater through advances in technology such as seismic profiling, and in this case, multi-beam bathymetry. Some of you may have read the work of Sanjeev Gupta, which has basically likened the floor of the seabed in the English Channel to the types of bed forms that can be observed resulting from the flood of Lake Missoula. But some work that we've been doing in association with the aggregate companies is really to identify drowned geomorphic systems, and from determining their response, let's say to the 8.2 acceleration in the rate of sea level rise, 8,500 years ago, we're actually getting additional information in terms of how geomorphic systems respond to accelerated rates of sea level rise. It's not just about drowning. You can see from this diagram, which is soon to be published, that there's all sorts of different responses, basically conditioned again by geomorphology and also by sediment supply. Okay, time's running on a little bit, so I think the one thing that I'm very keen to try and emphasise here is to just introduce you to a little bit of social science. I'm not sure whether you were expecting this afternoon. But this is a publication which is very well known amongst my social science colleague, the work of Sherry Arnstein. In essence, it's known as Arnstein's ladder. And on this, at the bottom, we have what's known as almost like a top-down approach to decision-making. So this would be where, let's say, for example, the CIA make all of the decisions. We just have to cope with whatever after effects there are. And then here at the top, this is where communities make the decisions. So the Water Framework Directive, for example, is all about trying to make sure that communities are involved in the decision-making. And I'd like you just to think about, where are you placed in terms of your activities? To what extent do you engage with decision makers, with stakeholders who are there actually making decisions about resource use? Probably many of you think that you might have some level of outreach, and in fact pathways to impact in most research council grants encourage us to do that nowadays. But this is where we should be moving towards, working in partnership with folks. You know, it's through that process of shared learning that's how we can convert the science, the good science in terms of what we're doing, to actually make a difference when it comes to coastal planning, coastal management, coastal decision making. So all I'm doing here is like she's trying to encourage you to think that perhaps the pathways to impact isn't a necessary evil. Perhaps that's what should lead our science. Just a thought. I'll skip through those. You'll obviously be able to focus on those when you look at the presentation subsequently, because it will be available there for downloading. I think the thing that I want to emphasise here is that it's almost part of our responsibility to make sure that we're providing decision makers and stakeholders with the kind of information, the reliable data, and to work in a way where we can discuss issues of uncertainty, discuss some of those caveats that might be lost. Say, for example, providing the diagram and they only see the diagram and they miss out on the caveats, which was part of Jonathan's presentation, I think yesterday. An emphasis on promoting dynamic coasts. Well, I think that's fairly well demonstrated in terms of the presentation. An emphasis in terms of enhancing coastal resilience by looking at system behaviour across scales, kind of trying to bridge the process with the geological understanding. And although I wasn't able to do it, but obviously we have modelling tools that enable us to explore coastal response, and therefore the feeding into some level of decision support. I think it's the last point that I really want to emphasise. I think it's almost like a scientific community's responsibility to make sure that our knowledge and our data are actually communicated to the people who should be using it. And I'd like to suggest that perhaps the people who are best at doing that are those climate skeptics. The folks who are all part of the scientific community are very happy to communicate with other scientists and perhaps aren't so active in terms of getting the message out there. The alternative side of the coin is the climate skeptics are incredibly good at getting their message out there. And I'm not sure whether there are any climate skeptics in the audience here, but at the same time, are there many coastal decision makers? Are there many media folks in the audience here? So, you know, I think that's probably part of my emphasis here. It's not just about identifying what the problems are. It's about trying to get to those solutions, and really it's dialogue that helps us to get there. Okay, so I'll finish there. Thank you very much.